Good morning, everyone. I'm Meghna DK, research scholar from Bangalore, India. Today, I will be presenting my work titled Performance and Efficiency Trade-offs in Transformer Models for Kannada Sentiment Analysis. These are my co-authors, and my paper ID is 254. So, if we go through the table of contents of the presentation, it includes introduction, literature review, the introduction about the transformer models, architecture, detailed workflow, dataset details, results, and conclusion. So, in the introduction, sentiment analysis is the process of interpreting emotions in the textual data. Now, social media has become one of the primary platforms for people to share their opinions. So, this sentiment analysis helps us to understand these opinions automatically, and which is very important for businesses, politics, and society. For high resource languages like English, there are abundant of labeled datasets. But for low resource languages like Indian languages, which include Kannada, Telugu, Tamil, Marathi, Hindi, we face some challenges like lack of labeled data and tools, the rich morphology present in the languages, and the frequent code mixing that happens with the English. In this work, we address these challenges by creating a Kannada dataset using a machine translation, that is Google Translate, and then analyzing how different transformer platforms perform on this. So, in the literature review, let me briefly touch some of the related work. Several researchers have built sentiment dataset for Indian languages using a Google Translate. For example, Indic Sentiment 140 creates a dataset for 140 languages, which covers 22 Indian languages. Models like PyLSTM, BERT, Mural, and IndicBERT have been tested, and Mural performs better on the Indian languages. Other works focused on the code mix datasets like in Tamil, Malayalam, and Kannada. However, the main limitation in these works are they all perform the comparison between the accuracy and difference score, and our work do the performance and efficiency trade-offs, which is crucial for the real-time applications. So for transform models, we have selected a 5 different models: IndicBot, StillBot, MBot, XLMBot, and Mural. IndicBot is a lightweight model optimized for Indian languages. It is a variant of AllBot that is very efficient. The StillBot, a smaller, faster version of the bot, which is designed on the basis of a knowledge distillation, and it is also a very efficient one. MBot, a multilingual version of bot trained on 104 languages, but it does not train only for the Indian languages. XLMR, a robust cross-lingual model trained on 100 languages, known for strong performance but a resource-heavy. Mural, a multilingual representation of for Indian languages, designed specifically for Indian languages, supports translation, transliteration, and code mixed text. So in the architecture, we take the English label dataset and we will Google translate it into a Kannada label dataset. And this dataset will be used for the fine tuning of transform models like IndicBot, Mural, XLM, Robota, Stillbot, and MBot. A classifier will be attached to a class token, and this will be used to predict the sentiments using these models. And then performance evaluation like accuracy, F1 score, inference time, and memory utilization will be computed. In the detailed workflow, English dataset will be Google translated into a Kannada dataset, and then a pre-processing and normalization will be done, and then this will be encoded into a numerical labels. The labels which are present in the English or Kannada labels will be transformed into a numerical labels. Then it will be split into training and testing dataset, and the 5 transform models will be fine-tuned using this dataset. Then evaluate the models and compare the effectiveness and efficiency of these models. So for this experiment, we have taken the dataset, which is a balanced dataset of 3,885 entries, and each class contains positive, negative, and neutral classes, and each one have 1,295 samples. And in our dataset, we have a English reviews, Kannada translated reviews, the sentiment and the sentiment score. The English review, like I really like the song Love Story by Taylor Swift, has been translated to Taylor Swift ಅವರ ಲವ್ ಸ್ಟೋರಿ ಹಾಡು ನನಗೆ ತುಂಬಾ ಇಷ್ಟವಾಗಿದೆ. And this is a positive review, and the sentiment score will be assigned as 2, and for negative we assign it as 1, and for neutral we assign it as 0. Even though the translation gives us the dataset, but it contains some of the errors and the vocabulary mismatch. But by fine tuning, we can get the dataset which is lacking for our training purpose. So, and this is our results. We can see here in the XLM Roberta we got 0.73 accuracy, and for Mural we got 0.71. Stillbird we got 0.62, Mbird we got 0.67, and for IndicBird we got 0.51. So from this we can understand the excellent Remota got the better performance of 0.73 on the Kannada dataset, and IndicBird got the least performance of 0.51. And if we see the efficiency trade-offs, IndicBird and DistillBird are the better performers with only 400 MB of memory usage and 0.0153 of inference time, and it is very efficient, fastest. And next to IndicBird is the DistillBird, which have the memory utilization of 1566 and inference time of 0.0693. And XLMR is the heavier one, which consumes 3199 of memory and 0.082 of the inference time. This is more resource insensitive, but it is a high performing for the multilingual concept. So this is the confusion matrix for the better performer XLMR and the least performer IndicBird. So as we can see, it classifies positive, negative, and the neutral in a better way. But if we see in the confusion matrix of the IndicBird, it is misclassifying the neutral classes more. So classification of neutral in terms of IndicBird is very difficult. So if we see accuracy versus number of epochs, so this Buryl, Ambert, XLMR, IndicBird, and DistillBird. So we can see IndicBird giving the least performance and XLMR giving the best performance, and we can see the accuracy keep on increasing for every epochs. So in the same way, if we see loss for every each epochs, so this is for Mural, Mbert, XLMR, IndicBird, and DistillBird. So for each epochs, the loss is decreasing significantly. So which tells that the transformers are training in a better way. So in the same note, if we compare the memory utilization for every epochs, so Mural, Ambert, XLMR, IndicBird, and DistillBird. So we can see that the memory utilization keeps on increasing in a very slight manner, which is not noticeable in these graphs. So to conclude, Mural is the best overall for Kannada due to Indian language optimization. XLMR gives highest accuracy, but it is a resource intensive. IndicBird DistillBird efficient, suitable for real time, but is less accurate. Mbird is a general purpose but not well suited for Kannada. So if we see in a overall, if the accuracy is increasing, it will take the much resources for training purpose. If it takes less resources, means the accuracy will be compromised. So if we see in the overall five transformer models, Mural performs better in terms of both accuracy and also the inference time and memory utilization. So these are some of the references, and thank you. So I'm open for questions.